From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Which I would say the first thing I learned when I was a young man actually working for my dad is your handshake. Your handshake is your word. So you have to have integrity. You have to be totally transparent with the customer, what's actually taking place, if you can or cannot service that customer. I guess the hardest part of sales or business development, whatever term we want to use today, is just really striking up that first conversation. Everybody's always nervous. So it's people connecting with people. And then it's people connecting with problems, then it's solutions to fix your problem, especially in this role. So in my role, it's that easy.
That's Craig Beaumier. Craig is the Director of Business Development at Accurate Brazing. Craig's career spans all forms and facets of business development and sales, and he has worked in companies of all sizes, from mom and pop operations to Fortune 10 companies. He's a military veteran and joins the show today to talk about the importance of thermal post-processing in metal additive manufacturing. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. All right, Craig, I'm excited for the conversation today. We haven't had kind of a true post-processing discussion on the podcast. And so I think this will be a really good, some good insight from all the work that you guys do. So I like to start all of my episodes with kind of more about the personal side, kind of who I'm talking to, kind of where'd you grow up, kind of what got you kind of on the path towards where you are today.
That's a great question. My career's it's busy, to say a better lack of words. So I grew up in the inner east side of Cleveland. I grew up in a blue-collar family, attended Cleveland public schools. Was one of those kids who were bused. That was probably a saving grace because I was probably sent to one of the first STEM schools. We called them magnet schools back then. And that really drove my interest in science and math, mostly science. Throughout high school, did sports, stuff of that nature. My dad was an electrician, contract worker. My mom was a teacher. So I grew up both kind of on the educational side, but on the blue-collar side. And I did both. I went to Kent State University, did my degree in education exercise physiology, joined the Navy. I wanted to be a PAR doctor, was involved in a few conflicts in the military. And that kind of gave my insight of material and different types of material. And then when I came out of the military, I taught school for 2 years. I was recruited into sales. I started my career in medical sales. I spent about 15 years of medical sales, first 11 years with Johnson & Johnson. Then I got the startup bug, started doing a bunch of startups in the late 90s, early 2000. They got exposed to more materials. What's really made it interesting is that I got to see ceramics and titanium and stuff of that nature. And during that career change, there was a little change in the industry during one of the administrations, and it kind of moved me over to the capital size of equipment, selling large equipment, big equipment for the material industry. And I went to work for a company called Quintus for about 4 years. And then during Quintus, I got a chance to sell hips and different technologies, got to meet a bunch of great, amazing people. And I got into the post-processing side where I landed here today.
Awesome. And so I'm always fascinated. I'm an engineer, introvert by nature. So I'm always an admirer of people who do sales and the way that they are interact and kind of watch how they work. So, I mean, give your 2 cents. What's kind of the key things that kind of a rube like me needs to know about kind of sales and what have you learned over your career on that front? Just as kind of, we talk a lot about engineering and we'll get into that here, but I think just as important in terms of thinking how a full business functions, you have to interact with people, you have to convince them of your product. But what have you learned over that period of your career and all the experience that you have on that front?
That's a great question. I would say the first thing I learned when I was a young man actually working for my dad is your handshake. Your handshake is your word. So you have to have integrity. You have to be totally transparent with the customer, what's actually taking place, if you can or cannot service that customer. I guess the hardest part of sales or business development, whatever term we want to use today, is just really striking up that first conversation. Everybody's always nervous. So it's people connecting with people. And then it's people connecting with problems, then it's solutions to fix your problem, especially in this role. So in my role, it's that easy. I just see it as simple as that. Some people try to make it more difficult than that, but we're people, we're human beings, we interact on a daily basis, and we just have to be comfortable with each other, and we have to be honest. And integrity is a big issue for me. You have to have strong integrity. You just won't be successful at all in this business.
And when was your first introduction to additive manufacturing? When did that come across your radar?
And when I was working at Quintus, when I was selling the hips, I first got hired over at Quintus, and AM was really taking off. With the hips and stuff, when I was selling hips, we were really focusing on MIM and castings. But as AM was developing more and more exposure to the AM market, which was quite fascinating. And when I started getting exposed to AM, there's still a lot of plastics going on. And then the metal printers started to really produce some parts, especially GE driving that, and was exposed to a lot of different products across the footprint with customers and stuff.
And so for those who may be more familiar on the plastic side or not super familiar with metal 3D printing, do you want to just go through kind of what is HIP and how does that fit into the overall process of 3D printing and production manufacturing? Like, what is it? Why do people need it? Why do people use it?
Well, it's funny, hipping, when you look at the history of hipping, hipping really started, cold isostatic presses started back in the 30s. 1939, some of that nature. Then hot isostatic pressing really started growing some legs in the 40s between Patel Institute in Columbus and Quintus in Sweden. But the first commercial use was done by Kennametal as well as Howmet Arconic. And what they saw hipping for, it's time over temperature with pressure, right? Equal amounts of force or pressure on a part to basically squeeze or remove the internal porosities, but increase the ductility and the strength of the part. And that's all hip. That's really what hipping is. It's time over temperature. You're pretty much getting that metal to a plastic state. You're keeping it near that shape, using isostatic pressure, and just removing that micro porosity in that part, and keeping it near that shape. So that's the basic of hipping. So when you look at the history of hipping, that's really when it took off with the titaniums and stuff of that nature here in the United States. And a lot of engineers start seeing if I have an imperfect part, especially internal porosity, I can improve that part without scrapping it, decreasing my scrap rate. So when you look at the history, it's how it really took off.
And so it sounds like a balance between, you said time over temperature, but if the temperature is too high, you're going to melt something and you're going to remove your shape, or something's going to go wrong. Too much pressure, same idea. And
it's really time over temperature with pressure. It's all about that pressure.
Yep. And with that, I mean, why is it special for additive manufacturing? And it seems like everyone I talk to, and a lot of certainly the metals folks, like hipping always comes into the conversation, or oftentimes. Is it a requirement, do you think, for most additive manufactured parts, or is it something that just really augments the process?
It augments. It's complementary because you're taking old data from the casting days, right? And now we know we're here in additive. You just can't use a traditional hip cycle. We have to use a unique hip cycle for some of this material. And ideally, in additive, we like to get away from hip. We like just stress, cut off stress relief parts, stuff of that nature. But some of these parts, you have to hip it to improve the ductility and the strength of the part. And so that's what's really interesting. So at first, when you look at the history of additive, they thought hipping wasn't for metals, hipping wasn't going to be necessary. And then we started learning that, well, hipping improves the properties of the material for the part. And now we moved along and learned out, hey, we just can't use traditional hip cycles. We have to use a unique hip cycle, or what we call today high pressure heat treat. You're starting to hear that term a lot, where we can stress, hip, anneal, and age in the hip and certain hips, like the Quintus hip here. And so that's starting to take place now. I can't use a traditional hip cycle on some of the materials I'm printing with. I have to create my own unique customized hip cycle, which is really interesting when you look at the market. So it depends who you ask and you talk to. Some will love, hey, I'd like to get away from hipping, but you said so nicely. When I do hip some of this material, it performs better. But it comes down to what am I printing the part for, and what's the application? So it always comes down to what's the application of the part, and what environment is that part going to be in? And we all know that hipping or high pressure heat treat hipping can improve that part.
And so walk us through kind of the process that a company that's printing metal parts, they've got a part that's ready to go into production. They know that hipping is going to be a part of that process. What do they do? So they print the part. Do they send the whole build plate to you? Is it kind of a thing that you work with them to kind of refine their recipe? How does that usually work when you're doing something for production?
All three. It depends where they're at with the part. It's quite interesting. I have seen it multi ways. I said, I printed this part. First time I put it into testing, it failed. Can you help us out? And then we do the post-processing in the hip or vacuum furnace or something of that nature, then send the part back on the build plate. Hey, the part did better. We have that scenario. Or we'll get a request saying, hey, we're thinking about using this material for this application, this part. What do you recommend? And they pull us in earlier, which is always beneficial for both parties because you haven't printed that part yet. You don't have that high scrap rate yet. Or thirdly, hey, we're doing some prototyping. Here's some dog bones. We want to talk to you about this, and what do you recommend? So you see all three depending on the project. What's always prefers to work the best so far I've seen in my career is you pull us in a little earlier if you're not sure on the material and the part and how you're printing it and what post-processing do I need to do. That always seems to benefit the customer the most.
And it seems often, this isn't unique to metal additive manufacturing, but certainly in the polymer space, that the further you get into it and the closer you want to get to production, there's more of the onion that needs to be discovered by the users. You think, hey, we're going to buy a machine, even if it's $1 million or $1.5 million, that it's going to be making parts next day or next few weeks. But then you start to uncover, hey, I need to go through all the testing. I need to get all the materials spec'd out. There's this whole level of post-processing that I haven't even thought about. And it's got to tie into my design and how I'm doing all that. And there's timing involved. So what's your experience on kind of the overall, I'd say, understanding of the supply chain for many of the users that you see these days, and how has that evolved over the last few years?
I would say it's getting better. And the reason it's getting better is a lot of the association and trade shows, a lot of conversation about supply chain, the ecosystem, how to support additive. In the beginning, it was not as robust. It was, hey, I have this part, I have this powder, I bought this printer, I want to make something. In today's environment, at least what I see is we're getting the post-processors, thermal processors, we're being pulled in earlier to ask us our opinion, how would you manage this, which is great because a lot of expertise out there in material. Remember, this is powder, right? In hipping and post-processing, we've been dealing with powder forever. So it's kind of nice that we get pulled in a little earlier to work with the teams on that. But also depends on the engineer who's working on the project or the design engineer on their comfort level of material and post-processing. We can get some customers who give us unbelievable specs, unbelievable ask, if you will, can you run this in the perfect cycle for the material? And then you get the one not as well-trained in a material engineer, hey, can you help us with this? So we see both. I've seen more and more that they're pulling us forward earlier to assist, which is beneficial, especially on the prototyping and the testing.
And are there specific materials that you like to focus on at the company these days, or is it all across the board?
You're asking a guy who likes hipping and heat treating, so anything metal I can put in my furnaces is fun, but a lot of titanium, alloys, Inconel, stainless steels, seeing a lot of aluminum right now in powder. A lot of aluminum is really taken off. We're seeing a lot of that on the hipping side. On the traditional vacuum heat treat side, every alloy you can think of that goes through the heat treat process we see, because we braze as well. So we braze, heat treat, and hip all underneath one roof. So we see all types of material across the spectrum.
And how, maybe just take a step back in terms of talk specifically about kind of the company and how does it work? Where you're kind of working, you have a lot of different clients across industries, across geographies, and you kind of have a number of technologies you bring in-house to do heat treatment or different post-processing applications to those. What's a kind of overview, kind of 30,000 foot view of the company, and how's what?
Well, we know we're a small company and a large corporation. I mean, Accurate Brazing been around since 1989. Was founded basically in a garage up in New Hampshire, and grew from there with the Francis brothers. Started a garage, opened up shop in New Hampshire, opened up a second shop here in South Carolina, then opened up another shop in Connecticut, then added hip and stuff of that nature. So that's kind of the history of the private ownership of the company. They were purchased by Alberts Group, second largest post processors in the world, back in 2006, I believe, something of that nature. I look at the data. So our portfolio is huge. So what's interesting, we're Accurate Brazing, but we're part of the Alberts Surface Technology Group. We have such a large brand globally and regionally that people, SEO search and stuff, they find us and they go to our website and say, hey, what can you help us with? I like to tell customers, ask us what we don't do as a group. So I have numerous sister companies that I can refer to help on some form of post-processing being, we do the vacuum heat treating, brazing, and hipping here. I have a machine shop down the street, have a coating company down the street, have traditional heat treat shop up the street. So it's best to ask us what we don't do. So when a customer finds us, they say, hey, we're looking at this project. Can you support us in this project? And then we just take it from there. Because again, if it's not underneath our roof here at Accurate Brazing, one of our sister companies in the Alberts group, we can refer them to. So our ecosystem is really broad, really deep for our customers. So if you want to say term one-stop shop, that's where we are.
And it's a mix, as you mentioned, between kind of doing that early prototyping, R&D, kind of short runs, kind of one-offs, two-offs, all the way to production. Is that right?
Oh yeah, we go. No, actually, we go from tensile bars, right, pre-prototype all the way to production. Traditional and legacy parts.
And how is, kind of getting back to that, the idea of supply chain within the additive ecosystem. I mean, one of the things that it's getting better, as you mentioned, but I can kind of continuously observe is just the number of pieces that are required to get a part to production. I think we had a conversation with a guy in the medical space a few weeks ago saying, yeah, like of our titanium implants that we're making, we have maybe 20% of the time is spent in the actual machine itself, in the printer. And then the rest of it is post-processing, whether it's machining, whether it's heat treat, whether it's measurement, inspection. And so kind of from where you're sitting, like how has the evolution of additive and getting better materials that get closer to matching production requirements, how has that kind of changed your business, or how do you see it changing in the overall kind of fitting into the overall additive supply chain? Is it moving ahead? Is it stalled? Where do you see it?
Well, it depends on the material and the customer. Again, what's nice about our group is that we have most of it in-house underneath one roof. So we can definitely support the customer, or we have a neighboring or sister company nearby. I do hear stories where hey, I in the machine, but I have to take it to heat treat, take it out, go get it hip, take it out, cut it off the plate, go get stress, take it out. And that does add to the length of the product. Again, as more of us progress as post-processors or thermal processors, we have to make investments, which we do here, to support that customer. If there's a need and it makes a good business case, we'll make that investment to support that customer. So again, our goal as a team here at Accurate Brazing is everything underneath one roof. Being casting or brazing or additive, how we can support you. And that's our goal. So we will make the investment as a group. That's kind of one of our marching orders, is support the customer. If that's an investment that makes sense for the customer and to support the supply chain, we make that investment. So it depends as you get to know your customers and what they're looking for, and you have these conversations, you share with them what we offer. And if it's a good fit, it can take some of that pain away from them, especially in the lead time, especially when we're trying to go from print to fly, print to install, print to build. There's that lead time. And it is expensive to try to bring all this technology underneath one roof. I mean, when you talk about hipping and heat treating and printers, it can get very expensive. So what's nice about, we understand that here at Accurate Brazing. So we try to take on some of that responsibility for them by supplying the technology that they need.
And one of the things that we're developing software that kind of tracks some of the quality chain. Like the interesting thing that we've seen is like, how do all of these different touch points of an additive part, starting from the material or even the design all the way to kind of finished tested part, kind of talk to one another? So how are you seeing kind of the communication between customers keeping track of all the data, saying, okay, hey, we had these 25 tensile bars in all different orientations. You guys are going to do some of the thermal cycling, some of the hipping, some of the kind of early R&D, and then kind of send it back to us. Are people figuring it out in terms of how to connect all of these kind of distinct physical steps in the real world with kind of the digital data that they're using to make decisions?
It's funny you bring that up. If you saw our whiteboard right now, we're kind of discussing that decision tree. What's nice here, we're again, with our team, we're very conscious of that, and we have upfront conversations right away with the customer. And with quality and stuff being in the same building, what's nice here is our hips in one building, you go 90 feet, you have your vacuum department and your heat treat department. So that part, touch point is doc, quality checks it in, we approve it, take it through the process, quality double checks it, get stamp approval and send it out. That's our process here. So it is improvement, but again, it depends on the vendor you're working with. I can't speak for all, but what's nice is technology, right? Software, looking at some of the ERP systems, stuff of that nature, it makes it a little bit quicker with the travelers, checking everything off. I would say where we still have a little delay is you get a request on the spec, how they want to post-process. Quality engineering looks at it and say, hey, we have a better idea. Do you want to try this? It's getting that conversation to happen a little quicker. Hey, we feel here from experience, we can help you with this by using this post-process heat treat cycle or HIP cycle versus what you're presenting. Hopefully that will benefit you in the back end of your testing, make your testing better. So we do insert ourselves occasionally with the customer from experience. Hey, we've seen this before. We have experience with this before. We're here to help. We'll make a recommendation. It's up to that customer to say, hey, I'd like to try it. And if it works out, it saves them a lot of money because they passed their testing or passed their test. They can move over to next level, be in production, whatever. So it's improving. We're getting better software, as you spoke with, from the AM customers producing better parts and better technology. And we're post-processing in better technology now by using high pressure heat treat HIP and stuff of that nature.
And maybe for those who are, maybe it'd be useful just like as you mentioned, you like to start kind of early. Ideal situation, you start early with a customer, trying to kind of be engaged in the conversations of kind of part design, or maybe even just start from the beginning. Like where is a good starting point for where some of your customers like to bring you into the process of developing a product? Is it kind of before testing, before they buy the printer, even like where are they kind of bringing you in, and how does that typically evolve into like some timing until you finally get a part to put in one of your HIPs?
That's a great question. It depends on the customer and the application of the part. I have been in meetings where I would see a drawing on a napkin. We're thinking this material, what do you think we should do? Or, hey, we have already designed, drawn out, here's the part, here's the alloy. Do you have any experience with this? Have you ran parts off this printer? Do you have experience with this powder? So again, it's such a buffet. Depends on who you're working with. I personally like, hey, the beginning of the project, here's what we're thinking. Here's what we like to do. What do you think? What experts can you bring in? Not just ourselves, but community experts that we work with on a daily basis, testing, software, lab, whatever. And how should we move forward on this project? Again, we'd like to be pulled in early. That's where we see the most success. But it's okay if we come in late to help out. Sometimes it just takes the project a little bit longer. And we all understand the cost of development of powder, development of product. We all understand that. So the quicker we can get that customer to production or to do that end sale back to the customer, that's what we prefer.
And what sorts of methods of inspection or testing do you have to make sure that whatever you're trying is working? Is it mechanical testing? Is it looking at CT at that level? What sorts of, like, how do you know you're successful with the part? Is it with what you're doing?
So that's a great question. So internally we have basic testing, mechanical stuff, a CT stuff we have to sub out. But again, if we're pulled in earlier and if it's an alloy we've worked with before and we've seen before, we can really coach the customer on, hey, from our experience, this is what we've seen, and coach the customer towards the correct thermal cycle for that material to give them success on the back end. We do no CT or stuff here. We have a vendor, or we work with her within the company that we partner with, or a lot of our customers, they want that product not to be tested by us, but be tested by a third party, which makes sense. So, and I agree with that. Let's take it outside the thermal processor's hand and let the third party test that part, which is always a good way to go. So again, but basically what they see on the spec and what alloy you're working with. All we can do is coach. We try not to tell the customer what to do because they're doing their own trials. We always can lead them down that path. But at the end of the day, it's the customer's final decision on how they want to run that part.
And I'm not super familiar with this, but like in terms of proprietary of recipes for different titanium, is that similar to what, I mean, we're kind of seeing a change over the machine side and kind of how people are printing parts where, okay, your process parameters for your laser and your layer thickness and all your energy density, people were really like, wanted to hold on to that in terms of like, that's their bread and butter, that's their secret sauce. But then at the same time, you get all these big companies sending those third-party testers all the same tensile bars made of all the same parameters, and everyone's kind of doing the same thing. You see starting to break through that a little bit now with some standards organization trying to make.
Yeah, you're starting to see the standards come out in AM where we're sharing the post-processing cycles, which is good. There are some customers that we work with NDAs and IP. That data will never be shared. Right. So it depends what goes out to print, but we live on NDA, so we never disclose who is what, where. We just use our expertise and here's what we've seen. We would never disclose, if you will, whose part did what, where. You'll never survive as a company if you did that. But as it goes out in standards, it's public knowledge. Right.
Yeah, and it's always a balance. It seems like there's more opportunities for kind of applications in some of these technologies, but as the upfront cost and time to get it to a point where you're at a GE level or Stryker or some of these folks that have spent decades at this point on manipulating the technology and manipulating the post-processing, getting all the recipes done. It just takes a while. So it's that balance between, okay, when is it, what is our competitive advantage and how long does it take for someone to catch up to do it, right?
I've been watching this for a few years now. It's quite interesting to watch the conversations take place. Like you said, everybody's looking for the secret sauce. At the end of the day, it's thermal cycles. It's what we do. It's what we run. It's hipping. But if a customer, you'll get that spec, customer ABCD with their number on it, that's their hip cycle. It's never disclosed. Again, until it goes to publication, or to a spec. So it's just the best way to do business. But again, if you pull us in early, pull the team in early, and all the experts, we can always help shape that narrative, help build that story for you, and get you to market quicker.
And over the time you've been involved with additive specifically on this part of the business, like what's one of your biggest takeaways? How have you seen kind of the general trend of the technology evolve? Is it continuing to accelerate? Are people kind of hunkered down trying to find those right niche applications? Like where is it kind of now as a hype technology now that it's been out for at this point kind of number of decades?
Yeah, the first AM machine was 1989,
almost 4 decades.
Yeah, it's been fun to watch, right? It's been fun to be part of. I always say what it gets me excited when I go to Rapid or AMUG or one of the trade shows, you just see more and more vendors, more and more companies, smaller companies really stepping out in front with this technology with some new alloys and new printers. I would say we're still, I want to call it, don't take the wrong way, it's still a wild, wild west, right? We know we can print a part. We've known from the GE stories and the Airbus stories and some of the stuff Honeywell's done, we can print, we go to production, we do good production runs and Stryker. Now, how can I get to big parts? How can I get to those large parts? That's fun to watch. Watch the printers get bigger and bigger. I've enjoyed watching that. The only question I say is, as they get bigger and bigger and bigger, how are we going to post-process them? Where are we going to put them? How are we going to handle them? Just like the casting days. I mean, you're looking at us right now where the casting world or the MIM world was. They're really just taking off with their technology and different alloys, and how can we apply these alloys to different business adventures, if you will. And it's a blast to watch. I really enjoy going to the AMUGs and the Rapids and just go to the presentations to hear the conversations and see what we're doing with additive. Now you have, in the firearm industry taking off, and now auto racing is really adapting one-offs, as we will, for additive, which is so much fun to watch. I enjoy it because, what's great about our job is, well, as I see it, I go on a field trip almost every day. I get to go on a field trip. I'm a 6th grader every day, getting off the yellow school bus, walk into a corporation or a company. I'm putting these 2 machines down. Here's what I'm doing. What do you think? I'm just like, wow, this is fascinating. As the powders get better and the machines get better and the printers get faster, right? Faster and bigger. It's so exciting to watch. The question is, where's the end? I mean, how big are we going to get? I mean, that's going to be the fun question. I mean, we're getting these 1 meter parts by 1 meter plates. We got some big parts coming out of these printers. So only thing that's going to hold back additive is the technology. How quickly can I build it? How well I can build it, and this scalability of affordability, right? Can I afford to go bigger? Is there a market to support it? And just like in the post process, is there a market? You can have the greatest technology, but is there a market that really wants to burden that cost with you on a new technology? So that's where I see, if anything, given a yellow light, not a red light, that would be it. But I always like watching also the debates on testing, as you said earlier, all the testing now. How do we test it? How do we prove it? Some of these parts we can't even get a scan for them. They're so big, they're so healthy. It's a great problem to have, right? So I think additives here and technology is going to catch up, especially the testing is going to catch up to it. And then once the testing catches up, additive they'll push the boundaries again.
And so as part of the conversations that I have with folks, I like to kind of give people some insight of kind of a day in the life. So would you like to kind of pick a random day, pick an average day for kind of what you do, and just describe kind of what the sorts of things you're seeing, and kind of do kind of field trips, as you said, but like what's an average day? What are the kind of skills that you're putting into use every day for folks who are maybe just starting their career and looking to kind of get some insight on what skills they may need to have to be successful?
You know, I always go back to the cartoon Dora the Explorer. You have to be willing to go out there and just kick up some dirt and go into factories or customers and just learn, just absorb when you're new to this business. I mean, you got to think, thermal processor, when we're making that changes, we're a very tenured group of individuals, a lot of tribal knowledge. And then you have us younger guys coming in that just doesn't have as much tribal knowledge. So we're trying to pull their tribal knowledges from the old days with new tribal knowledge from our days and mesh them together. It's interesting to do, because in this industry, a lot of this is on the job training, on the job learning. You have to work on the floor, you have to work in the lab to understand what you're working with. So my average day, I'm a nerd, right? So I like to get up. I have certain LinkedIn pages I go to, certain articles I go to, the AM magazine and all those. I like to see what's going on. And then, of course, customers' requests for proposals come in, or requests for support. You have to go through those. Then you have to do your customer visits, meet with your customers and work with them on their projects. And then, of course, we are in the business of selling something or moving something. So you always have the sales process, working through your quotes, negotiating your quotes, closing your quotes, and then you got to get it into production, working with your production team, operations, and then after they're done with the part, to make sure the part gets out to the customer. So there's a lot of balls in the air for us in our profession, because we're a small group here at Accurate Brazing for what we do. We're very, I want to say elite, we're a very lean team here. And I'm involved in the marketing with our marketing manager. We're involved in trade shows. As you know, Mike, you and I run through each other all the time. We're always bouncing around. So there's no boring days. So someone who wants to jump in this business, just go back to your days, not be scared to ask questions. There's no mistakes when you're learning. Go to the experts. Don't be embarrassed to say, hey, what are you using that part for? What's that application for? Some really great thought leaders out here, and I could throw a bunch of names out here right now. There's so many. Every single show I go to, I'm one of the first ones into the talks. If I go to AMUG or Rapid or MS&T or any of the shows, if there's a talk you're interested in, make that investment, go in there and learn and listen to the experts. And don't be scared to go up to those experts and ask questions, because they like to teach too. We work a lot of the national labs. I get a chance to go into some of the national labs and just really talk to the world experts in a certain material and have a chance to have a dialogue. And just be willing to absorb as much knowledge as you can. You'll never know enough. So that's the great thing about it. You're always learning in this industry. At least I am. And there's not a boring day. I don't know, between trade magazines and textbooks that I read, or just articles that are printed. A lot of great things coming in content now. A lot of the PhD students and universities doing great work in additive, and you can really pick up some really interesting trends. That's kind of my average day. I know I kind of went all over the place, but it's an average day for me is probably 10 to 12 hours. But it doesn't feel like 10 to 12 hours. It just feels like it's just had lunch and it's exciting. So, and I want to see more and more young people get interested in thermal processing or post processing because it's really fascinating. I mean, when you think about it's blacksmithing, right? I mean, everyone watches Forge of Fire. It's just a fancy Forge of Fire. I mean, you got a great opportunity to really see some amazing products. You see how this country moves, how it's made, and you have a chance to be part of that process. And how exciting is that? Every day I go home, there's a different story to share when my kids ask me a question. Or, Dad, what did you do today? I mean, I'm so privileged in our industry just to interact with some of these world experts on this material. I mean, every time I get in a plane, I don't know about you, I still smile. I still smile when the engine starts. I know somewhere in that engine, our team touched that part, or the landing gear, or the fuselage, or the seat. I mean, how could you not be excited?
That's awesome. And so, I mean, talk a little bit more, like, so some of those young people that are maybe coming into your company, like what sorts of backgrounds are they having? Like, what are you guys looking for when you're kind of building the team out, especially on folks on the younger side that are just getting their toe in?
You know, what's exciting to see is when you get between operations and business development, it's two different, but now we cross over, right? So it's exciting when you get a young engineer comes in, he or she, they want to learn first on the floor, working with the team with the vacuum furnaces and the brazing and the hipping, and then they want to go into quality. Then they want to dip their toe into business development, working with customers on specs and quality. Then they want to branch out and be a key account manager. That's kind of the progression. Or you get a young individual like myself who doesn't have a material background, you come on the business development side, and then you switch over and start learning about materials. So you have both avenues you can take. And that's what's nice about post-processing or thermal process. There's so many different areas of a company you can work within, and you can grow. You can go into maintenance, you can go into operations, you can go into safety. Depends what you want to do. So when an individual comes here, it's just a smorgasbord. Hey, what do you want to take a look at? What do you want to try? What do you want to learn? Put them into that department that he or she learn that, become well educated at it. Do you want to move on to the next level? Like we have some quality managers that really enjoy going out talking with customers. They just really like going on site, doing the site visits. That's just exciting for them in their development. So it depends. If you're coming in with a business degree, you can start in the business side, marketing the business and prospecting and stuff of that nature. If you come on the engineering side, material side, or quality side, you'll master that, then you move over to the business side if you like. Because that's kind of been my path.
And that one of the things that I've noticed, certainly over the last 5-10 years, is the diversity, at least certainly in the US, of like how many different additive is happening all over the place. It doesn't, it's in big cities, it's in not super big cities per se, a lot of the production, but just all across the board, right, and different states. And so from young people I talk to and meet, it's like, hey, like you get into this, you get a good skill set, like you can kind of work wherever you want geography wise, because there's stuff happening. It's moving.
I tell every young person in this industry, being on the print side or the thermal processing side, I've done business development, I've done project manager, right? Equipment install, selling equipment, go to the site. I've worked a little bit in operations with my operational background. I mean, learn a little bit about materials, still learning a lot about materials, but specs, NADCAP, ITAR, how to get these approvals. There's a customer I'm thinking back to, one of my young engineers started a larger corporation to start a new additive company. And he told me he's having so much fun because he's going from buying the equipment, being the project manager, doing the install. He made a statement. I didn't understand how much argon cost. I had to purchase it myself. Just something as simple as that. Yes, that gas is expensive. So it's just exciting him. He's under 30, I believe, and he's taking all this on as a 30-year-old who's an AM engineer. And now he is a director of additive as a 30-year-old, bringing it into a company, which I just excited to hear him talk, how excited he is. And it's fun to learn all those skill sets. You get a better appreciation of what all of us go through. I mean, I think about my customers who get a new machine, buy some powder, they're making their first part, and all the trial and error that they face. Doing that, going down that path with them and helping them and watching them develop, then see them become a larger company, then see them get purchased by another company. That's always, if that's what they like, that's always fun to watch.
And so we're a little bit more than halfway through 2022. What is on your radar? What's exciting for or what are you looking forward to the next few months of the year?
It's like aerospace is opening back up, and it's nice to see. And seeing more and more aerospace parts coming back to production. It's always nice to see here in the United States. Second half of this year, what I'm excited about, our team had a lot of prototyping parts earlier in the year. Now they're coming to possibly production. And that's really fun to watch and see in the space and aerospace application. It's so nice to see this idea we started back in December or January, and we got through the process as a team. Now we're seeing production parts. So the question in 23, 24, will we see them actually in use? That's what I'm excited about in the additive. I'm really excited to see some of these larger printers that we've heard about, or some of the parts we're seeing, start seeing some of those parts come off those printers and put them into post-process, see how they behave. That's going to be exciting to see. And some of the alloys that you're seeing from the space companies that they're working with, the great space race, I call it. Everybody's in the space race. It's nice to see what's taking place there as well. So the second half of this year, hopefully see more parts, if you will, come from that application.
Well, Craig, I really appreciate the conversation today, and look forward to seeing you in person in a few weeks. And I'm sure one of the upcoming trade shows.
Thanks, my man. I appreciate it. Have a great day. Thank you for